to Calculus 2. We just finished 8.6 before we left for the break. So I'm going to study 8.7 today. Alright, let's look at the first theorem, the indeterminate form or L'Hopital rule. This is theorem 8.4. Let f and g be functions that are differentiable on an open interval AB containing c, except possible at c itself. Assume that g prime of x not equal to 0 for all x in AB except possible at c itself. If the limit of f of x over g of x as x approaching c produce the indeterminate form 0 over 0 or infinity over infinity, then the theorem said you can take a derivative of numerator separate from denominator. However, make sure that it has to be in the form of 0 over 0 or infinity over infinity. Same thing if limit as x approaching infinity. If this condition satisfied, you can take derivative of numerator separate from denominator. Now let's look at example. Alright, the first example, limit as x approaching -4 of this function. Alright, if you remember Cal 1, we can, I think it's in chapter 1. If we substitute -4 in here, you're going to have 0 on denominator, which is undefined. So from Cal 1, we can simplify this first. Alright, if I try to simplify this, I would have limit as x approaching -4. I'm going to factor this. So I'm going to have x plus 4, 2x plus 5 over x plus 4. Alright, now I can reduce x plus 4 and x plus 4. Now I have limit as x approaching -4, 2x plus 5. Now I can do direct substitution. I can substitute -4 for x, which is -8 plus 5, which is -3. Alright, this is what we will do in Cal 1, chapter 1. Now, let's see if I want to apply the L'Hopital rule. Now I'm going to use the notation this instead of write everything out. Alright, so first thing you have to check the condition. Alright, you have to make sure that it's either 0 over 0, infinity over infinity, or some negative infinity, and so on. Right? So let's look at the original equation. Limit as x approaching -4, 2x squared plus 13x plus 20 over x plus 4. Again, if I substitute -4 on the denominator, I have 0. If I substitute -4 on the numerator, I have 32 plus minus 42 plus 20, which is 0 over 0. Alright, you must check this condition before you apply the L'Hopital rule. Alright, next I'm gonna use the L'Hopital rule, which means that I can take derivative of the numerator and then derivative of denominator. Right? Now I'm gonna use the L'Hopital rule. If I take a derivative here, alright, derivative of this would be 4x. Derivative of 13x will be 13. Derivative of constant is 0. and on denominator I have 1. Alright, now I can do direct substitution here. Substitute negative 4 for x, then I have negative 16 plus 13 over 1, which is negative 3, which is the same answer. Alright, let's look at the next example. I'm going to use Cal 1 first. Alright, so what I'm going to do, because x is approach infinity, I'm going to divide every single term by x. Alright, x squared actually. I'm going to take a limit as x approaching infinity. I will divide every term by x squared. So I would have 4x over x squared minus 3 over x squared. That's for the numerator. On the denominator, I would have 5x squared over x squared minus 1 over x squared. Alright, next step. See if as x, let me simplify this. Right, then I'm gonna have limit x approaching infinity 4 over x minus 3 over x squared. That's for the numerator. Denominator, I would have 5 plus 1 over x squared. Alright, as x approaching infinity, you're going to have 4 divided by a very big number, which means it's going to go to 0. Alright, same thing. 3 divided by x squared, as x approaching infinity, this will go to 0. So on the numerator, we have 0. Alright, on the denominator, 5 is 5. This one will go to 0, which is 0 over 0. Because we have this condition, I'm sorry, I make a mistake. It's just 0. 0 over 5 is 0. Yes, sorry, yes, no. Alright, so it's 0. Alright, this limit equal to 0. Now let's say if I gonna use L'Hopital's rule. As you can see, the condition as x approaching infinity, we have infinity over infinity. Alright, in this case we check that we have infinity over infinity. Alright, so we're gonna take derivative of numerator, separate from derivative of denominator. Then I will have limit as x approaching infinity. Derivative of numerator would be 4. Derivative of denominator would be 10x. Alright, as x approaching infinity, you're gonna have 4 over infinity, which is 0, which is the same answer. Alright, let's see next example. Let's look at example 3. We're gonna apply the L'Hopital's rule right away. Alright, first I'm gonna rewrite this a little bit. Alright, so this is limit as x approaching infinity. If you remember the rule of the log, I can bring the 4 exponential up front, so I'm gonna do that. Next step I'm going to do is that I want to make sure that I can apply the L'Hopital's rule. If x go to infinity, I would have infinity on the numerator and infinity on the denominator, which means I can apply the L'Hopital rule. Make sure you have to check this before you apply the rule. Alright, now I'm going to apply the L'Hopital's rule, which means I'm going to take derivative of the numerator, separate from derivative of the denominator. Four is just 4, alright? derivative of ln x is 1 over x, which is x over 4. 4 over x. And then derivative of x to the cube, it will be 3x squared. Right? That's derivative of numerator. 4 is just 4. Derivative of ln x is 1 over x. And derivative of 3x to the cube is 3x squared. Now I'm just going to simplify this a little bit. Alright, so you can see. So this is limit as x approaching infinity, 4 over x times 1 over 3x squared. Now I'm going to simplify this a little bit. That is limit as x approaching infinity, 4 over 3x to the cube. Now as x go to infinity, you're going to have 0 divided by infinity, which is 0. That would be the answer. Alright, so let's look at the example number 4. As you can see, it's as x go to infinity, you're going to have e to the infinity, which is infinity over infinity. So we can apply the L'Hospital rule. So I'm going to take derivative of numerator, separate from denominator. Alright, so this is going to be a limit as x approaching infinity. Derivative of e to any exponent is just e to the x over 2. However, we have to take the derivative of the exponent, which is 1/2. Derivative of x is 1. Now if I as x approaching infinity, you're going to have e to the infinity, which is infinity over 1. So the answer would be infinity. Alright, let's go to the next example. Alright, let's look at example number 5. As you look at this example, if you substitute x approaching 1, ln 1 is 0. Alright, psi of pi is also 0. So you have 0 over 0. So we can apply the L'Hospital rule. So what I'm going to do, I'm going to take derivative of numerator, separate from denominator. Derivative of ln x is 1 over x. Alright, derivative of psi pi of x is cosine pi of x. But I have to take the derivative of pi x, which is pi. Alright, now I can do the direct substitution. Alright, as x approaching 1, I have 1 on the numerator. As x approaching 1 here, I have cosine of pi. Cosine of pi is -1, so I have negative pi. So the answer is -1 over pi. Alright, now let's look at the last example for part 1. Alright, I have this function, this limit as x go to 0 of this function. If you substitute 0 in here, you're going to have 0 over 0. Alright, which means I can apply the L'Hospital rule. So let's do that. I'm trying not to block the board here. So as x approaching 0, derivative of x is 1. Right? Now on the denominator, I'm going to apply this theorem here. Alright? Arch tangent of u is equal to u prime over 1 plus u squared. Now look at my equation. My u will be 2x. Alright, my u will be 2x. My u square will be 4x squared. Alright, and my u prime, which is the derivative, which will be 2. Alright, now I'm gonna substitute all of this here on the denominator. Alright, then I'm gonna have u prime, which is 2, over 1 plus u square. 1 plus u square is 4x squared. Maybe I should draw a line longer so you don't confuse here. Yes, this is my derivative on the numerator. Alright, so if I direct substitute x equal to 0, I'm going to have 1 over 2. This whole thing will be 0, which is 1. Alright, so the answer is 1/2. Alright, this is the part 1 of 8.7. I would like you to practice the homework, the easy one, just do evaluation of L'Hopital's rule. We're gonna go to part 2, which is a little bit more abstract later. Thank you.